guys heard of battleship before? It's the idea of using the ones on the vertical line is like your one dimension, and the one on the horizontal line is another dimension. Before we go on, I do have to tell you one more quick mathematician's name, and the French teacher will be talking about him on one of his famous quotes. His name was René Descartes. Anybody know that name? René Descartes. Very good. When you think about graphing and the XY plane, let's clean this. When you think of graphing, you're actually talking about René Descartes, okay? Some of his work. So let's just talk about it for a second. We'll finish Pascal's triangle, and then we're gonna have 10 minutes of intense math. Intense math. We're gonna do intense math, and then we're gonna stop, okay? And then we'll do something else after that. So this is Pascal's triangle. We're gonna start there in a second. Since it's already there, we might as well just do it, and then we'll talk about René Descartes. So with Pascal's triangle, the idea is I add these two numbers up, and it gives me this number here. And then I say, then I notice there's always going to be a 1 on the outside. That's always going to be constant. But what's going to happen is that I can derive more values. So let's actually do this activity together. These two together will add to give me 4. These two will add together to give me 6. These two will add together to give me 4. So basically, the first line, 1, and then 1, 1, and then 1, 2, 1, and then 1, 3, 3, 1. Where did I get the 3 from? I added these two numbers together to give me that 3. So this is something that is sometimes called Pascal's triangle. Blaise Pascal was a French mathematician who lived a very short life. He died at the age of 39, which was actually the same age that Martin Luther King Jr. died, which is interesting. I'm just saying that's an interesting random number for both, but they both died young. But if we can look at Blaise Pascal and some of their cohorts, they died, so Pascal died at 39, but the unit for pressure is Pascal. That's one of the units we use. The unit for measuring pressure can be in Pascal. So it's named after him. The calculating machine, one of the things that he came up with while he was a teenager. So his dad used to work in a field where they were required to add up stuff. I think it was like an accountant type person or tax office. So they would be dealing with adding up numbers, and his dad would have to stay up late at night. Pascal, at the age of 18, was able to come up with a calculating machine idea that has helped us down the line. So just because someone is young doesn't mean they can't do great things. That's number one. Number two, just because someone's life is short does not mean that it didn't add a lot of value to the world. Make sense? So it's not about how long, it's about how well. Now, I pray that you all live long. I hope I live long. But ultimately, you shouldn't just be banking on living long without making the most of today. Every single day, we should say, I want to make the most of today. So Blaise Pascal, we have Pascal's triangle. What is it used for? The problem is if I tell you what it's used for, it's actually more of an Algebra 1, Algebra 2 concept, and some of you might just tune out. That's the problem. But if it's okay, maybe I'll just tell you a little bit of what it's used for, because it will help with CLEP preparation. So let me just try. So please, can you buckle up for 2 minutes, and I'll just tell you. So here's what it's used for. In math, there's something called a binomial. A binomial is something like, basically it's two numbers. Bi is usually like a bicycle, 2 tires, right? That's the usual word there. So a binomial would be something like this, A plus B. Everybody see that? Okay. In math, if you raise anything to the power 0, the answer is 1, okay? So if I raise A plus B to the 0, the answer is 1, okay? So pay attention to that. Okay, if you raise anything to the power 1, the answer is just that thing to the power 1. I mean, it's the same thing. Pay attention to that. If you were to raise something to the second power, okay, and I promise we're going to stop here, we're going to slow down the train in a second. A plus B squared, it is the same thing as A plus B times A plus B. If you raise something squared, you're going to get the same thing written twice. So for example, if I say what is y squared, it's the same thing as y times y. What is 4 squared is the same thing as 4 times 4. So what is A plus B squared is the same thing as A plus B times A plus B. That leads me to the one algebra concept of today, okay? And I know some of you are young, you've not done algebra, that's fine, but there's a point. The point is, whenever you have two things multiplying like this, you can use this with numbers, by the way. For example, what is 7 times 7? Well, 7 times 7 is the same thing as 3 plus 4 times 3 plus 4. Now, that's not very efficient to do this, but I just want to show you the point. 7 times 7 is the same thing as 3 plus 4 times 3 plus 4. And if I ask you to multiply that out, again, this is not efficient, but it's just showing you the concept. You could take the 3 here and the 3 there and say 3 times 3. And then you could take the 3 here times the 4 there, plus 3 times 4. Then 3 times 3 here, 3 times 4, and then 4 times 4, and that's 16. What is 3 times 3? 9 plus 12 plus 12 plus 16. You can add all those up together, and the answer is 49. Not efficient, okay? This is not efficient. I do not recommend you doing this at home. However, it showed a point. The point it showed is that we can do the same thing if it's letters and not numbers. How do we do that? This will become a times a plus ab plus ab plus b squared. That's true. It's the same thing I just did with the numbers. So then this becomes a squared plus 2ab plus b squared. When is Pascal's triangle used? Here's the answer. Notice that it has a 1 in front of it here, a 2 here, and a 1 here. Doesn't that match the 1, 2, 1 over here? It does. Pascal's triangle can be used for multiplying big details of numbers and getting the answer easily. I'm sorry if that was painful. We are done with algebra for a second. Okay, so let's delete that. I just wanted you to know that Pascal's triangle from the French mathematician Blaise Pascal, and he was a physicist and a theologian also. He was all of the above. That's that. Okay, let's come back and land our plane before we wrap up with prime numbers. So another French mathematician that we talk about is a man by the name of René Descartes. René Descartes. And what is one famous thing about him? If you've ever seen an XY coordinate graph before, we call this the x-axis, we call this the y-axis. If you've ever seen this, you should probably be glad that René Descartes existed. He was a French mathematician and philosopher, and he used to tutor the Queen of Sweden at 5 a.m. or so. Not a good idea. You don't want to be tutoring in Sweden at 5 a.m. He died of pneumonia at the age of 54. But René Descartes was very influential to the work of people like even Albert Einstein later on. And so Descartes gave us this idea that you can think of like your street. Think of where you live, whether you live in Moorhead or Fargo. And think of the avenue, right? That you might live on something avenue and something street. So if you say I live on 3rd Avenue and 4th Street, then that might be that location. Everybody see that? That's the coordinate. So when you think of your street, think of like coordinates, and that's part of what René Descartes helped us with. Is the idea of the Cartesian. It's called the Cartesian plane. Everybody see that? That's the name. It's called the Cartesian plane, named after our friend René Descartes. I might not be pronouncing the French word right, so Charles, your homework is to tell. Well, how would you pronounce his name? Okay. Why don't you ask and tell us tomorrow how to pronounce it? Because
it's basically like what you said.
Well, how I'm saying. Okay, so René Descartes. Yep. So René Descartes gave us that. So today we've talked about a few French mathematicians. Let's land our plane with the people, and I want to end with the most important topic in pre-algebra today. The first mathematician we talked about is Pierre de Fermat. He gave us Fermat's last theorem, which was shown to be true by an English mathematician named Andrew Wiles, who, by the way, I didn't know this when we were at Oxford, but Andrew Wiles is now a professor at Oxford. We should have looked for him, and I will look for him, of course, politely, and email him and beg if I can talk with him. It'd be great to chat with him. He won an award, a big award for the work he did. And remember, some of these awards that people win come with a lot of funds. You'll be fine. You'll be able to pay your rent. Let's just say that. Okay, that's number one. So we have Pierre de Fermat. We talked about Blaise Pascal, who was a French mathematician. He came up with the Pascals, or they talk about him with the reference to Pascal's triangle, even though honestly I would say it's hard to attribute it to just one person. But Blaise Pascal, Pascal's triangle. The unit for pressure, Pascal. The calculating machine, Pascal. Okay, so Pascal was influential. Wrote some great books, died at the age of 39, but revolutionized the world. The third French person we're talking about is René Descartes. René Descartes, Cartesian plane, famous for the saying, I think, therefore I am. That's from René Descartes. Okay? A couple more, and then we'll talk about prime numbers to end the day. There's another mathematician by the name of Fourier. Fourier, his math is what partly drives the medicine machines that are running the world today. So when you get a CT scan, or you get an MRI scan, the computers are using a principle called Fourier transform to give the images to the radiologist to treat you. Math runs medicine. Math runs engineering. Math runs everything that matters. Literally. If you matter, math runs you, probably. Because math and logic are very connected. And math is the foundation. So logic is the foundation, and then math builds on logic, right? And then chemistry, physics, biology. Well, biology is a little different because it deals more with memorization and so on. Okay, so if you go home today, can you say that you know some French people? You could say that. You know a few. The most famous chemist in history, one of the most famous chemists, most influential, was also French. His name was Antoine Lavoisier. Lavoisier, unfortunately, was taken away during the French Revolution. Everybody heard about something called the French Revolution? So that happened during the French Revolution. Antoine Lavoisier was somewhat wealthy. He lived in the 1700s, and they thought he was a bad guy. And so they took him, and let's just say it didn't end well. We'll leave that alone. But that's what happened to Antoine Lavoisier. The world lost one of the best chemists of all time. Let's talk about a few more French names. Napoleon was French. He's not a mathematician, but he was influential. And he lived in the 1700s to 1800s. One of our teachers is actually going to talk to you about Napoleon on Thursday. So you guys who are doing the French week, you could learn about Napoleon. Napoleon was an interesting character. But one of the things that happened in the 1700s to 1800s is there's a field of study called mechanical engineering. War actually powers engineering sometimes. Did you know that? Because sometimes you're looking for a way to conquer your enemies, right? And I wouldn't say that Sadi Carnot did what he did just because of that. However, there is chemistry that is tied, and mechanical engineering, tied to a French guy called Sadi Carnot. You can look him up. His name is spelled C-A-R-N-O-T. Okay, let me draw you a picture, and we'll call it a day with math. Sadi Carnot, okay? So here's the picture that I want you to keep in mind. On the base is logic. Logic is just the way to reason properly and clearly. On top of logic and so on is a field, of course, of mathematics. Well, mathematics has concepts that are arithmetic-based, addition, subtraction, multiplication, division. And that's my first level of assessing people's math ability. Can they add, subtract, multiply, and divide? Then the next level up from there is, do they know how to prime factorize? Then do they know how to add fractions, subtract, multiply, and divide fractions? Then do they know how to do decimals? Do they know how to do ratios and proportions? If you know how to do everything I just described, you are ready for algebra. There's no reason you shouldn't be in algebra. Now, what is algebra? Equations, graphing, inequalities, polynomials, systems of equations, rational expressions, radicals, quadratics, functions. That's algebra. Now, most people in this room will fall into one of those two camps. You're either in pre-algebra or you're in algebra and college algebra. College algebra and algebra are pretty much the same, right? And they're the precursor to pre-calculus. So everybody in this room is either in pre-algebra, algebra, college algebra, or pre-calculus. You're in that span. Geometry is just dessert. Okay, leave them on the side. Geometry is dessert because it's like finding the area of a circle, perimeter of a square. That's geometry. Okay, so mathematics comes here, and there's different brands of mathematics. On top of mathematics is physics. The French gave us logicians, they gave us mathematicians, they gave us physicists, and they gave us chemists. Okay, this is a little bit of the structure when it comes to learning math and science. Logic and mathematics, physics, chemistry. So mathematicians don't have to learn physics or chemistry. They're fine. Physicists have to learn mathematics and logic, and they're fine. Chemists have to learn physics, mathematics, and logic. Do you notice the pattern? You only do the thing below you. So if you're down here, you're good to go. I don't think it's possible to have a degree here and not have a job. I just don't see it being possible. And if you're proactive, like, you will have a job. I don't think you could be a physicist who is serious and not have a job. Like, it's just impossible, it seems. Chemistry, maybe. But the point is, notice the more you get to pure math, it's almost like you're fine, right? And this is now tied with computer science. Many colleges will teach that your degree is math and computer science. That's the degree. You don't just, I mean, some people will have the computer science, but smaller colleges will teach it as the two. Why am I saying all that? Because my goal in teaching is also to help you make decisions about your career. And the sooner you know your direction about career, the sooner you should be mentored and so on and so forth. Okay, I know people have to leave, so let's end, as I promised, with prime numbers. This is the last thing, and then you guys are done with math for today. I know you guys wanted to learn just French, but there's a lot of math. Okay, a prime number is a number that is only divisible by itself and 1. That is called a prime number. Prime numbers came from a guy by the name of Euclid, who lived around 300 BC. Euclid lived 300 years before Jesus, and he wrote a book called The Elements of Geometry, which is on the shelf there. You could read it. I have it in Greek and English. Euclid was a very influential mathematician, and he gave us a topic called prime numbers. Leonard Euler, my friend, one of my best friends, he died in 1783, but Euler built upon Euclid's work. If you know prime numbers and prime factorizations, you will be an exceptional math student. I repeat, if you know prime numbers and prime factorizations, you will be exceptional because it teaches you how to break numbers down. For example, what is the prime factorization of 20? You break it down and you find out it's 2 times 2 times 5. Those are the prime numbers that make up 20. If you give me any student and they just master prime numbers and prime factorizations, we're good to go. That's all we need. Why? Because that will help you do lowest common multiple, greatest common factor, adding fractions with unlike denominators, and the rest is history. So what is one of the most important topics in all of pre-algebra? Prime numbers and prime factorization. And you can choose to argue all day, but I think that is my case. I've kept you long. You've learned a lot of math, some math history. My goal was really to establish this today, because today is more of a math emphasis day. But Tuesday through Thursday, you guys will have the regular French week opportunities. Dr. Marianne will teach you French and French songs and teach you about some of these people. And then in the afternoons, I'm going to try and see if we can do more soccer and things like that. Because the greatest country in soccer, for the most part, is France. So it just makes sense to play soccer. France won the World Cup in 2018, and they literally almost won the World Cup in 2022.
Who won this